Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Today we want to present about artificial intelligence case study. Firstly, my name is Muhammad Haris Haikal and my teammate is Cyrus Basil, Muhammad Zorih Ashraf and Wan Rashdan. So artificial intelligence is already impacting our life every day. Technology companies such as Google, Microsoft, Facebook, and Amazon are continuously embedding AI in their product line. The AI revolution has not only benefit technological company, but it has also been adopted by a wide range of industries. So next, artificial intelligence in agriculture. So AI can provide farmer with real-time insight from their field, allowing them to identify area that irrigation, fertilization, or pesticide treatment. Also, innovative farming practice like virtual agriculture may help increase food production while minimizing the use of resources. The result is reduce of chemical and better harvest quality, higher profit, and significant cost saving. So next slide. So this is the application of AI in agriculture. First one is crop yield prediction and price forecast. And the next is intelligent spraying, predictive insight, agriculture robot, crop and soil monitoring, and the last one is disease diagnosis. So I will pass to the next presenter.
Okay, thank you, Haris. So this slide is for the benefit of implementing artificial neural network. So before that, my name is Muhammad Zul Ashraf. Okay, for the first one is to monitor the price fluctuation of the crop. So due to unstable price, farmers are never able to plan definite production pattern. So this problem is highly prevalent in crops like tomatoes that have very limited shelf time. Second one is to solve the security of resources and labor to large extent. It will be powerful tool that can help organization cope with the increasing amount of complexity in modern agriculture. The third one is smart sensor which can detect pest and disease infection. And the last one is higher adoption of robot in agriculture, which is many robot have implementing the AI technology to improve their efficiency in agriculture. So next, I will pass to the next presenter.
Hello, and thank you very much, Zorif. My name is Cyrus. I'll be presenting on the suitable training data inputs and outputs for the agriculture. So what we've chosen is making a system that is able to predict when's the right time to sow tomatoes with a different temperature. So based on the inputs and output, right now there's only there's only single inputs and a single output. Obviously, there's going to be a single output at the end of the day, but inputs for now we just focus on temperature because different temperature will give a different output on when's the right time to sow. So say right now the best temperature to sow tomatoes is at around 21 to 27 degrees, while a bad temperature range around 10 if it's below 10 degrees or above 35 degrees. So in the output we can see the number 0101. So 0 meaning it's not the right time to sow, it's bad, it's dead, and if it's 1, it's a good time, it's a better time. So in this table it's one way to predict when's the right time to sow those tomatoes at a good temperature. Because not every day or every week or every month we'll have a suitable temperature for the tomatoes to grow. And we just chose tomato. We can choose other things, other fruits, other agriculture benefits, but we just chose tomato because it's the most simplest thing when we did research on it. So the table on the left represents the input and output. Tables on the right represent the range of the right temperature for the tomatoes to be sown. All right, next slide. So artificial neural network architecture in predicting the time to sow tomatoes. So what is this? This is network architecture. It is a complex structure made of artificial which require multiple inputs to produce the output. So in the previous slide just now, it just shows the input as a temperature. So for now, maybe we can put multiple, we will still continue in tomato sowing. But right now, maybe the input can add on the day, the temperature, and the weather outcome. Say, because all three of these, not because every day is going to be a different results. Depends on the weather and the day and the environment, basically. So there is a three layer, that is the input, the hidden, and the output layer. This is required to make the prediction at the output. So like so now the diagram represents multiple layer connection like a spider web. And the input contains nodes to the hidden layer and output connection to the input through the connection weight. So by doing so, it will predict a better and output a better time to sow the tomato on which day, on which time, and a right temperature based on prediction of the weather and forecast. All right, next slide. So the training function is that sig module is a function is the most suitable activation function for this case study, which is used by each neuron on a multi-layer. Then we have the training function is we're using the train CG for the training function. It is suitable to perform well on a wide variety of problems with large number of weights. It has the modest memory requirements as a training function. And that's all from my point. So I'm going to pass next.
Okay, I'm the next and the last presenter. My name is Marasdan bin Marosli. And from my part is I will tell you about the suitable performance function that can be used to gauge the performance of the ANN model. There's two. The first one is MAE, that's mean absolute error. MAE measure the average magnitude of the error in a set of predictions without considering their direction. It's the average over the test sample of the absolute differences between prediction and actual observation, where all individual differences have equal weight. For the second one is the root mean square error, known as RMSE. RMSE is a quadratic scoring rule that also measures the average magnitude of the error. It's the square root of the average of squared differences between prediction and actual observation. The similarities between both of MAE and RMSE they both express average model prediction error in units of the variable of interest. Both metrics can range from 0 to infinite and are indifferent to the direction of errors. They are negatively oriented scores, which means lower values are better. The differences between both of this is that taking the square root of the average square error has some interesting implication for RMSE. Since the error are squared before they are average, the RMSE give a relatively high weight to large errors. This means the RMSE should be more useful while large errors are particularly undesirable. Okay, thank you. That's all from us.